Good evening to all of you. Today we are going to discuss about structure, property, what is coordination complex. A coordination complex is formed by a transitional metal and a ligand. A transitional metal is that metal which have an incompletely filled vacant d orbital. The ligand donates electron towards the central metal, resulting dative bond, and that is the cause of complex formation. Now, whenever you talk about a complex, it may be cationic complex, it may be anionic complex. Just like that, ligand can be positive hydrogenium ion, it may be negative chloride ion, it may be neutral also. Simplest one is water. Now, a complex salt differs from a double salt. Suppose double salt, if I consider Morse salt or potash alum, a complex salt will not give the test of the central metal and the ligand, which is written inside the third bracket. That is also called coordination sphere. You are not going to get the positive test of the part which is inside the third bracket, that is ligand and the central metal. But when you talk about a double salt, say for example potash alum, you are going to get the positive test of potassium ion, aluminium ion, sulfate ion. What is the test of sulfate ion in the laboratory? Salt solution, barium chloride, white precipitate, insoluble in concentrated nitric acid. That is the test of sulfate ion. So all the tests you will get for a double salt, but which is not possible in a complex. The part which is outside the complex, that gives only positive test in the lab. Obviously you can get the test. You have to break this complex using nitric acid, then only you will get the test. But normally we say that we do not get the test of the part which is inside the third bracket. Now all of you know ligands may be a variety of type. Normal ligands, negative ligand, neutral ligands, positive ligand, ambidentate ligand, which can donate from two different sites, chelating ligand, variety of ligands are there. And this is known to all of you. But what is a complex? What are the practical application? This coordination complex is actually used for analytical purpose. For example, the estimation of nickel can be done using DMG, and it can be estimated gravimetrically. Gold, just react with sodium cyanide, it will form AgCN twice. Then just react with zinc, you will get precipitate of gold. That is how gold is prepared. Nickel, form nickel tetracarbonyl, because carbon monoxide is a pi acid ligand. It forms complex with nickel easily, and that nickel tetracarbonyl, when it is heated further, nickel is formed. So metallurgical, these are metallurgical uses. In case of biology also, chlorophyll contains the central metal magnesium. Obviously that is not a transitional metal, but these are exceptions. Lithium aluminium hydride, aluminium is the central metal, that is complex but no transitional metal. Aluminium is not a transitional metal. If you talk about cyanocobalamin, this cyanocobalamin, that is the vitamin B complex, central metal is cobalt. These are actually organometallic compound. If we talk about ferrocin, it is used as anti-cancer drug. That is also a complex of iron. Ruthenocin, central metal ruthenium. And if you talk about the porphyrin complex, that is hemoglobin, you can see the structure already I have drawn in the board. It is not possible to draw this thing while I give the lecture. You just see the board. This is the structure of the hemoglobin. And you see this iron is the central metal. These are nitrogen donors. This is heterocyclic bases. These 5 heterocyclic bases are there. And there is the 6th coordination. This is the oxygen which is we are inhaling. That gets ligated towards the central metal in hemoglobin. And that is the oxygen which is supplied in the body. This coordination complex can be also used, say for example, cisplatin. This cisplatin is an anti-cancer drug. And if you look at the structure of cisplatin, this is actually a geometrical isomer. This is cisplatin. This is cisplatin. Similar groups are close together. This is called cisplatin. This is anti-cancer drug. But you see the magic of chemistry. Cisplatin This is transplatin. This is similar group, this part just away. This is not an anti-cancer drug. This is anti-cancer drug. So coordination complex, where you have the central metal, that is a D block element, or it may be a block element. Some exceptions are there. Exception is the rule of science. Example is lithium aluminium hydride. This is a complex. Chlorophyll, that is also complex. Central metal is magnesium here. So central metal is required, 99% case, D block element or F, and there should be ligand which will donate electron towards the central metal. This central metal have vacant d orbital, ligand will donate electron, and that results in the formation of bond, that is coordinate covalent bond. Already I have told this thing at the starting of this video. And if you talk about a complex, this is ligand N, this is the central metal, this is the ligand, this is inside the third bracket, that is called complex part. If I write K4, FeCN6, this is called potassium ferrocyanide. Here potassium is plus, this part is minus. So this complex part is minus, this is called anionic complex. But if I write this complex, this is minus, so this part is plus, this is called cationic complex. So based on a cationic complex or anionic complex, you can have the nomenclature different, that is IUPAC system. In case of a anionic complex, this iron will be written as ferret, but here cationic complex normal name will come. And if you talk about the ambidentate ligand, this is the ambidentate ligand. You see the formula is same, but the property is different. Say for example, I write two complexes of cobalt. This is a complex. I write another complex. Both are complexes. You see the donation is from nitrogen. You see the donation is from oxygen. This type of ligand is called ambidentate ligand. And ambidentate ligand gives rise to your linkage isomerism. Now how I will understand? Because in the board I am writing, you are also learning, but practically how will you understand this ambidentate ligand? If you look at this complex, this will be red. Suppose I give you this complex in a test tube to you, it will be red, this one is yellow. You see formula is same, cobalt, cobalt same, ammonia 1, 2, 3, 4, 5, same, 5. NO2, nitrogen 1, oxygen 2, nitrogen 1, oxygen 2. But donation site is from oxygen, donation site is from nitrogen, linkage is different. That is given by an ambidentate ligand like NO2. It may be thiocyanide ion also. This is also ambidentate ligand. Cyanide ion, it can donate from carbon as well as nitrogen. So these are a type of example of ligand. Chelating complex already I have discussed. This is called ambidentate ligand, very important type of ligand. And this linkage, if I give you these two complexes, the infrared spectra will distinguish these two complexes in the infrared spectroscopy machine. Thank you.